So continuing off the previous video, now let's take a look at number 6, where we have to find the limit of the limit as x approaches 0 of 1 minus 2x raised to the power of 1 over x. So if I go ahead and first use direct substitution, plugging in 0 for x, we get 1 minus 2 times 0 is 0 to the 1 over 0 power. So then we get 1 raised to the 1 over 0 power. Now obviously 1 over 0 is undefined, and this is not in any of the indeterminate forms like 0 over 0 or infinity over infinity. So what we have to do here is go back to the original limit. So go ahead and erase this half. And then we have to find a way to get it in an indeterminate form like 0 over 0 or infinity so we can use L'Hopital's rule. Now whenever you have an exponent that includes a variable like x, it's probably a good idea to use this process. And so the first step is to set the limit equal to some variable. Let's just go ahead and call it c, because we know that the limit is going to equal some value, and that value in this case we put it as c. Now the next step is to natural log both sides of the equation. So we have natural log of the limit as x approaches 0 of 1 minus 2x raised to the 1 over x power, and that's going to equal the natural log of c. Now whenever you have a limit inside a natural log, you can actually just bring that outside the natural log. So you rewrite it as the limit as x approaches 0 of the natural log of 1 minus 2x raised to the 1 over x power. That's going to equal the natural log of c. Now using properties of log, remember you can bring an exponent down in front of the log. So now I can go ahead and rewrite it as the limit as x approaches 0 of 1 over x times the natural log of 1 minus 2x, and that's going to equal the natural log of c. And one more step here, I'm going to go ahead and actually rewrite this as one whole fraction, putting the x on the denominator. So I'll rewrite it as the limit as x approaches 0 of the natural log of 1 minus 2x over x, and that's going to equal the natural log of c. Now for this next step, I'm just going to focus on the left side of the equation. We do need the ln of c later, but we don't need to focus on that right now. So rewriting the limit as x approaches 0 of the natural log of 1 minus 2x over x. Now if I go ahead and use direct substitution here, plugging in 0 for x, we get ln of 1 minus 0 over 0. ln of 1 minus 0 is ln of 1. ln of 1 is 0. We do get 0 over 0, that indeterminate form, so we can use L'Hopital's rule. Once again, in L'Hopital's rule, we're going to take the derivative of first the natural log of 1 minus 2x. So whenever we derive natural log of some inside function, in this case 1 minus 2x, we take the derivative of the inside function. So derivative of negative or 1 minus 2x is negative 2. And we take that over the inside function itself, so negative or 1 minus 2x. And that's going to be over the derivative of the denominator. Derivative of x is just 1. So we are left with negative 2 over 1 minus 2x. So now rewriting the limit as x approaches 0 of negative 2 over 1 minus 2x. Now I can go ahead and use direct substitution. So we get negative 2 over 1 minus 2 times 0 is 0. 1 minus 0 is 1, so we get negative 2 over 1, which is negative 2. Now even though we have found the limit to be negative 2, remember this is not the final answer, because earlier we set the limit equal to the natural log of c. So this entire limit we have found to be negative 2, so now we go ahead and set that equal to ln of c. So we need to find what that limit is, or what that c value is that we put as the variable. So all we have to do is e both sides, because then that'll get rid of the natural log. And what we're left with is that constant, or that actual limit, is e to the negative second, or 1 over e squared. And that's the final answer.